Hi, welcome back to the online statics review sessions. This session about the shear moment diagrams, which is one of the most important subjects in statics that will continue with engineers, designers throughout their professional experience. In a previous session, we started with internal forces or internal reactions, and you learn how to find a shear, the normal, and the moment at any point in a member, in a structure member. The reason we need to have a diagram that shows the change in the shear moment because along the structure, these shear and moment would change a normal too, would change from one point to the other depending on the change in the load. For designers, it's very important to know some of the values of these moment and shear and normal, including, for example, maximum values, positive and negative values, where exactly the location of these maximum and minimum values, where's the change, where's the zero values, where's values that changes from one point to the other. And therefore, drawing the shear and moment drawing a diagrams will give more information about the change in these values. So before we start, probably I've mentioned that in a previous session, we need to always, whenever you take the cut, always take the assumptions. If you look to the left, then the shear, given assumption that shear downwards, the normal is coming out or to the right, and the moment is turning counterclockwise. And if you cut and look to the right, then the shear is upwards. The normal is coming out of the cross section or to the left, and the moment is turning clockwise. The main reason for that is because when we draw the diagram, we will have to make sure that where is the negative and where is the positive where we can plot. So if you get a negative answer, then you have to plot it at the bottom of the member. If you get a positive, then you have to plot it at the top of the member. So to continue, a most important note also, what is the relation between the load and the shear and the moment? It is an integration relation. So if you integrate the load once, you get the shear, and if you integrate the shear once, you get the moment. This also gives us a lot of information about the shape of the line. So you integrate a constant, you get to a linear, you integrate a linear to get a parabolic or second degree. The also gives you information about how the slope, what is the relation in the slope. So the slope of the shear curve is equal the intensity of the loading, and the slope of the moment curve is the intensity of the shear. And to get the change in the shear is just get the area under loading, or change in the moment is the area under the shear diagram. I will give you important tips that will help draw the shear and moment diagrams with the minimum calculation possible that you can, with some of the notes, and also doing example. But main advice that I advise you is to do as many problems and examples as you can to get yourself very familiar with how to draw a shear and moment diagrams. If we look at this beam, which is supported at both ends, we just work with a shear diagram at a moment, so we exclude the normal. It's much easier, and this is the subject. It's covered in statics. It's just working with the shear and moment. If we move with other sessions for mechanics materials, then we will talk about the normal diagrams too. But shear and normal, first, the change in the intensity, or we always move from left to right when we draw the diagram. We have to pay attention in a change in the load. Any change in the load will reflect a change in the shear and a change in the moment. So the first step is always in the calculations is to find the support, all support reactions. Unlike when we, in the previous sessions, when you took the cut, and before taking the cut, you thought which side would be better to find the internal forces, and then you found only this side support. But the first step is always finding all support reactions, and then start by drawing the shear and moment diagram. Here, if you one of the important notes, uh, always you will see in a shear diagram a drop or a jump whenever there is a concentrated load in the load diagram. So here we have a drop. If you're not sure, simply take the cut immediately before and then try to find the shear, and then you will find it. So when you take the cut, remember that the shear has to be downwards, so downwards, and AY is upwards, so shear is equal exactly the AY, or the support at this point. Notice that you take it immediately after, which means that the distributed load is multiplied by a zero, so that's why it's not considered in that case. And then we move, if you take a cut. So the other important note, if we know that this is a constant, then we know that the shape of the line has to be, yes, linear. So which means that it will be a line that goes to the other side of the beam. If you cut immediately before, now notice here that it has to start from zero and end at zero. End at zero means that you will have the shear starts with the value of the support at the left, which going upwards, and it has to end also at zero. So I can actually plot both points and then connect them with the diagram. So this way that you probably don't need to do any calculations, but if you need to do any kind of calculations, then you just simply take the cut and find what is the magnitude of the shear at this point. If you take the cut, remember, taking the cut looking to the right, then the shear has to be upwards, and together with the upward sum of the forces in the y gets you that the shear V is equal negative By. That's why it is plotted in the bottom, or below the beam. After that, drawing the moment diagram, an important, very important note is that whenever you have a zero shear, then you will have a maximum moment. Remember, we said that the intensity would give you the slope. So you have a zero shear, which means you will have also a zero slope. So the slope at this point is zero. The other important note that it's because this is linear, then this is also, you will get a parabolic, or the second degree. Another important notes, and I summarize these in in the table that you will see shortly. If you need to find what is the magnitude, you can simply get the area of this triangle is another. Also, or you can just cut at the point where zero is and then find the moment, internal moment. There are many methods that you can find what is the moment. Also, how the shape of the why is it went up and not down. You see here, this is positive decreasing. So this positive decreasing means that the slope of that moment is decreasing, so it goes from big to zero. That's why it goes up, and it is positive, in a positive direction. So these are some of the notes that were summarized. Again, this is here the note where the shear is equal zero, and it will give you a maximum moment at this point. Another important case that you will see, we mentioned before in the previous slide, that you will see a drop in the shear diagram wherever there is a concentrated load. So I could draw the shear diagram simply by just working from a left. So there's first a drop. This is a constant, integrating a constant, and this is zero. Integrating a zero gets you a constant, and then there's a drop down. And in a previous session we had example to cut before and after, and we've seen that the only difference from before and after is the magnitude of the force with the direction of it. So I can right away say that it goes up to the AY, and then goes down with the magnitude of F1, and then 0, which means that it has to be constant, and then drop down with the value of F2. So this way we just drew the shear diagram without any calculations. It's just with information or that we know, or the relation that we know between the load diagram and the shear diagram. So this is constant, that this is 0, then the line is constant, 0 constant, drops in the direction of the force, drops down. If you're not sure about any of the values, just take the cut and find the magnitude of the force. Here, if you take a cut before, it's all the same from that point to the before the F1, and after you will see a drop in the diagram with the magnitude of F1. So how we draw a moment diagram. I'm doing that without any magnitudes, but just to give you some important tips about drawing the diagrams. So you see in the moment diagrams, the only drops you see in the moment diagrams are wherever you have a couple moment or free moment like that. You don't see drops in the moment when there's a concentrated load. You could see a change in the shape of the line, or a change in the slope wherever there's a change in the load magnitude. So if you just immediately cut at this point and then try to find some of the moments, you see they are both rotating in the same direction. So counterclockwise, which means that you will get a negative value. So the first step is that you have, and it's equal. So the internal moment immediately at this point where the distance is 0, x is 0, so you don't multiply ay, so you have m as plus ma is equal 0, or m is negative ma. So another hint, whenever you see that the moment is rotating in counterclockwise, then you have a negative value of the moment, or drop in a negative direction. So the other important point is at this point. So you will, if you just take the cut at this point, and then try to find what is the, so then it is take the cut and find the moment, so it will be ma rotating, and minus you have ay times x. And you notice here that it is that ma is nothing more but the area of this block. So it's ay times a, and then remember that this is what also it is mentioned in the first slide or the second slide, that you can get the intensity of the diagram by just getting the area of this part. So or by just cutting at this point and then define. And then I know that if this is only just the force, and it's supported with this force F2, then there should be no moment. So, or M is 0. So I know that this point M should be 0, and there's no major changes. So if this is constant, integrating a constant, you get a linear, then you just connect it with this line and you're done. So notice that this is the positive side, that's the negative side. This indicates that you will have also, you'll see this in when you continue with mechanics materials, about where is tension and where is compression in the beam. So this also indicates that there is a tension on the top and there is compression in the bottom of this part. Important points, important locations would be where the maximum moment is, whereas there's a change in the moment, maximum shear, there's a change in the shear, and also at the support. It helps us also to design the supports in when you move on with the design. Um, I summarized these in two tables. I want you to review these two tables that shows you um, what is the load type. So if it's single with nothing in between, so you have single forces, then which means that you have a 0, then it is a constant with positive jumps at upward single forces and negative at downwards. So this is exactly as what we did in a previous slide. You have positive drops or negative in a downward drops. The You can review this, and then you have line. The shape of that is just a line increasing if left supported upwards, and decreasing if left support is downward. So if left support is upward, it will be increasing, and if you look back here, if left support is upward, then the line is increasing in the positive form and a negative to the positive. So these, if you just can review these two important slides about the tables, it just explain the shape of the line and the relation. And in a summary, if the load is an n grade, then the shear is n plus 1 grade, then the moment is n plus 2 grade of the load here. So let's do an example. How to draw the shear and moment diagram. And I will skip here finding the support reactions that you have learned from previous sessions. So we calculate first the support reaction, and we found that you have AY upwards 11 kilonewton, moment rotating counterclockwise 24 at this point. Remember, this is fixed support, this is a roller support, and this here is pinned at this point. And then you have CY is given to be 5 kilonewton. At this point, this is a very important change in the load and change in the moment diagram. Where is it pinned at this point? That we have to pay very good attention to that. So we start drawing the shear and moment diagram. This is the points where there's a change in the intensity or the slope or in the shear and also in the moment. And why is that? First of all, this is because in the load, there is a change in the load from distributed load to 0, and then there is a jump and until you get to the end. So these points are very important in drawing the diagram. So we start by drawing the diagram as you learned and read probably from the two tables. You start with AY up with the same intensity, so it's 11 kilonewton. And then at this point, you need to find out what is the load or what is the shear. So you take the cut and look to the left. Take the cut immediately before the pin, because we don't want to be at the pin where you have the pin reaction. So you just see the shear at this pin, and then take the cut, write the equation. So you have sum of the forces is equal 0, so in the y, so you have this 11 minus VB going downwards minus 2 times 3 the length, and it's equal 0. So you have V is positive 5, which means that I have to plot V here at positive 5 and then just connect it. This is the point where V is equal 5. Also, you can just simply, if you see here, this is just minus this area, and it's the 2 times 3, or also it is the area of that load, which is the 5. So if you continue from there, then at this point I know that this is a 0, then I can just simply continue with constant, and then I know there will be a drop from positive 5 with a magnitude of 10. Then I'd go from 5 positive to 10 negative, it's minus 5, and then 0 constant, and then with the magnitude of cy goes up. This is all. So the only calculation you needed is just to find what is the magnitude at this point. You could have had it from this side or from that side. Following is drawing the moment diagram. We know that this moment is going counterclockwise, but if you're not sure that, and then it means that it has to start with a jump in the negative side. But again, if you're not sure about that, then just take the cut immediately after and find the moment, and then it'll be a moment is negative 24, because you have, remember that positive rotation, and this is also rotating positive, then it will give you negative 24, which means that it is negative 24. Now, a very important note: whenever there is a pin, what do we mean in the moment? What should be the moment equal to at a pin, which allows rotation? Correct, it should be 0. So this is a very good information that will help right away to draw the moment at this point. So I know that the moment has to cross at this point and become a 0. So, and this is linear. Integrating a linear, you get a curve, you get a second degree. Now also it is, the intensity is positive decreasing, which means that it will be positive going up, and the slope is decreasing. So you have a slope, a bigger slope here, and you have a smaller slope here, right? And it is, and then it goes constant. Then I know that it has to be linear in this line, but I don't know where exactly will it be. So I could take the cut on the other side and say that the moment is just simply is that cy times 1.5, or it is equal to 7.5. So I just took the cut from the other side, and looking right, then moments is clockwise, that's why it's negative, and the cy is positive multiplied, which is also nothing more but the area of, if you're looking to the right, the area of this here. So it is 5 times 1.5, and it's equal to 7.5, and it is positive. Then you plot the point and then connect it with a linear, and then I know that this is linear, this is 0, the moment is 0. Then I just connect this, and that's the constant, then this is linear, and you're done. So this gives you some hints about drawing the shear moment diagram. It's big subject. You can follow these hints and the tables and do as many examples and problems as you can, and then just go and see your professor or the TA and ask them, let them review that, go back to these slides, and which will help you a lot in understanding the concept of drawing a shear moment diagram. Thank you and see you in the next session.